And then how do I make myself large?
You are large.
I am large.
I think that's just a, yeah. I think that's just a matter of
stories about you, but I guess I can't do that now. Okay, so let me go ahead and begin. I was going to begin by saying, I listened to Professor Kwan yesterday, and certainly agree with everything he said. And his the heart of what he was saying has to do with the heart of work in math being to find the joy in it, and I certainly agree with that. I'm going to sharpen that a little bit, however, and these remarks have to do with both math and physics, that the doing of research, I think you students today may have a little bit harder time really grasping this because there is so much information available to you through the web that I think sometimes you may get the idea that research means doing Googling something. And certainly you can find information that way, but that's not really what research is about. Research is about problem solving, something that is not done before. Now, in the course of doing that, you should become expert on the whole subject that you're working in. And that does take library work, that does take, Google work and so forth, reading a lot of things to know that history. But the point of research is to build on that history of what others have done and to put your own creative energy into solving some new problem. So if you are, I don't want to demean, looking for information, but if that is all you're doing, what you're doing is reorganizing information that is already known, and that is not necessarily of great value to mankind. So we want to encourage you to be creative and take on problems. And when you get through your university work and you perhaps go on, whether it's in industry or to some other scientific or mathematical institution, you will have a whole lot of skills to bring to that world of high-level problem solving. Now, there are some differences between the research in math and in physics, and I don't want to draw too sharp a line because there is a lot of overlap, but there's some natural differences, and that leads to some people preferring a math-type line of work or preferring a more science, physical science kind of work. And I have gathered around me, you can't see it all, but I have gathered around me here at my desk what essentially are some of my toys for math and science. And so I'm going to start with this one, which I think you can all tell what it is, right? It is the simplest possible Rubik's Cube. And what is interesting about this? Well, maybe the fact that it is a cube is a little bit interesting, but that's probably not terribly interesting. But all the things you can do with it, right? And these are transformations that form a group, and it has to do with symmetries. And I was interested to see that one of your talks today, the last one of the day, is going to be on symmetries. So you might see something related to this coming up in your last talk today. So on the other hand, I have this other thing here, and I wish you could hold it because it's all about the holding of it. It's another cube, right? And they are actually the same size. But this guy is made of tungsten. And if you are in chemistry or other hard science where you know the periodic table, you know that tungsten is one of the most dense elements there are. In fact, these two things, this is 36 times the weight of this. As I'm having a little bit of difficulty holding it up over my computer. I don't want to drop it on my computer because I will break my computer. Okay. So if you were holding these two things, the first question that would pop into your mind is, why is this so heavy, right? That's not a math question. It's not necessarily even a physics question at the time you say it, but why is it so heavy? Well, why questions in the world around you very often lead you in deeper and deeper into science. So if you focus on this guy and ask, why is it as heavy as it is? Well, let's do the easier thing. Why is this as light as it is? Well, you could probably answer me that it's made of plastic. Plastic is carbon and oxygen Those are lighter atoms. They form loose networks in plastic, so there's a lot of space. And in fact, inside of it, there's a whole lot of space. So all that makes it not very dense, right? This guy, it's not only a heavy element, but it's a metal. And you may know that atoms of metal get up right next to each other, and they just naturally form denser structures. Well, that leads you to another question. This isn't a solid, but it's my pretend model. If I've got atoms at two corners here, and they want to be this far apart, why do they want to be that far apart? That has to do with the structure of the atom and the way atoms link together. Well, that's the world of chemistry. And in order to understand that, what do you need to know? We went from the world of Galileo and falling apples of Newton and so forth, which is the very old school world of gravity. Now to answer that question, we got to the world of quantum mechanics. So if you really wanted to answer that question of why, you would be led from a very basic idea of gravity that you could do in your own home to quantum mechanics. Why do things bond the way that they do? So science has a way of doing that. If you're asking why questions, you may be pushed by your own question to deeper and broader avenues of science that maybe in the beginning you didn't think you would want to do. When I was in college, I was afraid of coming out of college and going into a company and being put behind a desk doing statistics on a computer. So in college, I did a very stupid thing. I did not take any computer classes, and I did not take any statistics classes, so that when I got out, there would be no chance I would be put behind the desk doing statistics in some company. Well, I went into physics where I thought I was safe. Well, guess what I ended up doing? I ended up doing statistical mechanics, which meant doing a whole lot of statistical things using computers, and I was unprepared, okay? So I thought I was so smart, but I outsmarted myself, and I ended up having to learn that stuff all over again anyway, because science made me do it. Okay, so science is a lot like that. And since I raised gravity already with this big thing, if you really try to understand gravity, well, it turns out gravity around the world we live in is actually pretty weak, even though this is very heavy. But if you really want to understand gravity, we're led to the world of general relativity. And I was interested to see your third lecture today is going to be about gravitational wave astronomy, which is going to tell you things about that. So, but I'm sure all of you use GPS somehow, maybe in your family car, or maybe through your cell phone to find directions. And you may or may not know, if you want to use GPS, you have to use general relativity, because the timing of signals bouncing back and forth between the Earth and satellites requires general relativity in order for GPS to work. And so it goes on and on in science. So your questions of why often lead you broader and broader into subject matter that you maybe initially didn't think so. But if you're doing research and your question is why this, you are pretty much forced by your own drive to solve problems to learn more and more things. So I want you to remember that. In mathematics, it doesn't necessarily not happen that way, but within mathematics, at least you can define a world in terms of some axioms and logic, and you can work things out from there. And of course, that leads you to more and more discoveries of other math as well. So I don't want to say that doesn't happen. But one of the biggest differences between sciences and math is in science, there's no right answer. Ultimately, we have to compare whatever we do in science with the results of experiment and nature and just do our best. And we may believe we have the right answer, and it may be close to what we see in experiment, but we never are sure until the next experiment. So that's a fundamental difference between the nature of work in math and nature of work in science. Okay, I think I have taken enough time here at the beginning. If there are any questions for me, I'm only happy to answer. When we're done here, I'm going to set my computer aside, but I will be still listening to things going on just for my interest. Don't let that make you nervous. but I am interested to hear what you were doing. So have a good day and learn a lot.
Thank you, Professor.